Hi, we're going to use the slope-intercept form of an equation to work with graphs. So we're going to end up having at least three different forms of equations for lines, and this is probably going to be the most common and the most popular. And it's called the slope-intercept form, and it's y equals mx plus b, where m is going to represent the slope and b is going to represent the y-intercept. Both of these are characters from your recent math past, and they're going to be working together. So when we take a look at slope-intercept form, anytime you read a question that's going to use slope-intercept form, it's probably going to be helpful if you write down y equals mx plus b right away to get your mind going in that direction. And the first thing I want to look at is if you were given an equation in y equals mx plus b slope-intercept form, can you make a graph? And I say you can. So here's how this would work. Based on this information, when I look at this red equation, the y-intercept, the b, is 3. That means I'm going to hit the y-axis at 3. So in this case, I carefully count up 3 units and put a dot. It's because my y-intercept is positive 3 units up on the y-axis. Now my slope is 2/3, m slope 2/3, so that means in my head I'm thinking some version of rise over run of 2/3. So from that spot I can do a rise of positive 2 and then right 3 because my run was positive 3. Up 2 over 3, put a dot. Do it again. Up 2, right 3, put a dot. Up 2, right 3, put a dot. And you could actually go crazy too, because if you did a negative 2 divided by a negative 3, a negative divided by a negative is still a positive, so that's the same thing as 2/3. I could do fall of 2, left 3, negative 2 down, going downward, negative 3 going to the left. No matter which way you slice it, you get on the same line. And this happened by taking the y-intercept, plotting it, the slope, counting it. All right, let's do this next one. Y-intercept negative 4. On the y-axis, I go down 4. Slope is negative 2. If I want to think of it this way, I can think of it as a rise of negative 2, a run of positive 1, or a 2 over negative 1. Both of those are going to give you the same thing. They both divide to be negative 2 for the slope. If I chose this one, down 2 for my rise, right 1 for my run, down 2, right 1, down 2, right 1. If I chose this one, my rise is positive 2, my run is left 1. Up 2, left 1, up 2, left 1. If you do this, you should end up with a pattern that stays on the same line. And there we go. So from the graph, if you're given the equation, you can go straight to the graph, plot the y-intercept, then plot the slope. Plot the y-intercept, then plot the slope. On the example over here, we're given a graph. In this case, I'm going to work with the red one, and we want to make an equation. Well, that graph has a y-intercept in the red one. The y-intercept, which is the b of 3 units up on the y-axis, so I call the y-intercept 3. The slope is negative because it's going downhill, and now I'm going to count my rise over my run. I rise down 3 because I'm going to start at that point and I'm going to head to that point. So I have a 3 downward and a 6 to the right. Now I could think of that negative as going for this 3. Negative 3, positive 6. Or someone else could have said up 3, left 6 for a positive 3, negative 6. Doesn't matter which way you do it. The bottom line is the slope of that line is negative 1/2. And so now if I wanted to make the equation, I would say y equals mx plus b, and then just fill in the gaps. The slope is negative 1/2. The y-intercept is 3. And I have the equation of that red line. Let's take a look at the green line. Here it is. My y-intercept is down here, 1, 2, 3, 4 units down. So my y-intercept is going to be negative 4 or 0, comma, negative 4. My slope looks like this thing is going steeply uphill, so it's going to be a positive slope, but I'm going to count it. I'm going to start here and go to here. Up 3 over 1, or up 3, right 1. Positive 3, positive 1. So my slope is 3 over 1. Someone else could have said, hey, I go negative 3, negative 1. Negative 3, negative 1. That would also work because both of those end up equaling 3. So now with this information, I write down y equals mx plus b, and then I fill in right beneath it y equals 3x minus 4, because my y-intercept was negative 4. So those two exercises are pretty related. Whether you're going from equation to graph or graph to equation, you're really looking at a y-intercept and counting a slope. In the case I'm going to show you now, we're just given 2 points and we want to find the equation of that line in y equals mx plus b form. Well, one thing we have to notice is that this is a very special point. That is a y-intercept. So I'm going to take a quick moment to talk about y-intercepts. A y-intercept is always going to have an x value of 0. So in this case, I know my y-intercept for this ordered pair, or let me restate that. This ordered pair is a y-intercept because its x value is 0. 2, 7, that's not a y-intercept. 8, 0, that's not a y-intercept. It does have a 0 in there, but that's the y-coordinate. So any y-intercept you see will have an x value of 0. I can show that by simply doing this. If I were going to plot 0, 13, it'd be somewhere up there. But if I were to plot 2, 7, that'd be somewhere over here. That's not a y-intercept. If I were to plot 8, 0, it's over there. That's not a y-intercept. So your y-intercept is always going to have an x value of 0. So with that in mind, when I look at this example and I want to find the equation in y equals mx plus b form, I already have my y-intercept. It's 4. The other thing I need is my slope, so I'm going to have to calculate that, but lucky for me, I'm good at calculating slope. I think y minus y over x minus x, 4 minus a minus 2 over 0 minus 7. 4 minus a minus 2, and going in the same order, 0 minus 7. So I get a positive 6 over a negative 7. My slope is negative 6/7. As soon as I know my y-intercept and my slope, I can go ahead and make the equation. And now I have it. And by the way, if I take these 2 points that I was given and I just put them on this little makeshift graph and I graph it, it does make sense with this equation that I got. This equation says plus 4 y-intercept of 4, negative 6/7 for a slope. It's not so obvious, but this is going in the negative or downhill direction, thus negative, and I could count negative 6, right 7, negative 6, positive 7. So the picture seems to match the graph. Another thing you'll be asked to do is convert a different equation into y equals mx plus b slope-intercept form. These are two different types of equations that we're going to run across in the near future. This is called standard form. This is called point-slope form, but you don't care about that right now. You want to convert it into y equals mx plus b. And the thing that you want to tell yourself is anytime I need to convert into y equals mx plus b, I need to solve for y. We did that earlier in the year where we would take an equation and solve it for a particular variable. So I'm going to solve for y. I'm going to solve for y in that one, and that's going to automatically put it in that form. I'm going to pause the video and work this out, and then I'll show you that work. Okay, let's take a look at this first one. My goal was to take this equation in standard form, convert it into y equals mx plus b, which means solve for y. So I take the 2x, send it to the other side. Now, that would leave the equation looking like that. To get y by itself, I need to divide by 4. And so here's a little thing from your algebra past. When I divide by 4, it divides into both of those. So I'm going to rewrite this that shows the 4 dividing into both of those. And now this part, 2 over 4, reduces just a regular old fraction. And 20 over 4 turns into 5. But you'll notice that I now have y equals mx plus b. I know the slope and I know the y-intercept. I'm going to do the same thing over here. I need to solve for y. Okay, here's my original equation. The first thing I'm going to do is I'm going to distribute that 3/4 into the parentheses. After I do that, this minus 6 needs to head over to the other side by doing plus 6. By doing those two things, I end up with y by itself, and I have put the equation into y equals mx plus b form. Okay, there's a lot going on here. You might want to go ahead and practice. Let me show you what I mean here. You might want to go ahead and take these two equations and practice the algebra and see if you can do it on a blank sheet of paper, getting y by itself, and then compare it to my solutions. These are the fundamentals for graphing in y equals mx plus b form. In the short-term future, we'll also apply this to story problems or modeling real-world situations. See ya.